Hey guys, in this lesson we would understand what is quadratic formula and how to apply it and what does it do. In the previous lesson we understood that quadratic relations can be converted from one form to another, and we also understood the method of converting standard form to vertex form. That was called completing the square. However, in this lesson we would understand how to convert standard form to factored form. For converting standard form to factored form, we have two different ways. One is called factoring. Factoring we learned in one of the previous units, that was polynomials. The whole unit was dedicated to factoring. So what factoring does is convert standard form to factored form. And in some cases, when factoring is not possible, then the second method that can be applied is called quadratic formula. So always remember, quadratic formula would always work to convert standard form to factored form. However, factoring would work only in certain standard form of equations. Therefore, we have to understand how to apply quadratic formula in order to convert standard form to factored form of quadratic equations. Let's understand this with an example. Let's say we're given this equation y equal to 7x squared plus 24x plus 9. We know this is given to us in standard form and we have to change it to factored form. The factored form general equation is y equal to ax minus r x minus s, or the two bracket form is the factored form. The process that we will be discussing here to convert standard form to factored form is the use of quadratic formula. This formula is very important as this is useful to convert any type of standard form of quadratic equation to factored form. The only step that we have to follow to convert standard form to factored form is to apply quadratic formula. And the formula is negative b plus minus square root b square minus 4ac divided by 2a. Make sure the whole thing is divided by 2a, not just the second term or the first term divided by 2a. Now, what is this ABC in the standard formula is going to get substituted by is, let's take the example question. The question we are given is y equal to 7x squared plus 24x plus 9. Because we are going to apply quadratic formula to standard form, and we know standard form of equation, general form is ax squared plus bx plus c. So a, b, c are these numbers that are in front of x squared and x term. C is the number that is the constant by itself. So what we will be doing is we will be writing a, b, c separately. A we have is 7. Make sure the signs in front of the number also go with these alphabets. Here all the signs are positive, so all ABCs would be positive. A is positive 7, B is positive 24, and C is positive 9. Now the quadratic formula is negative b plus minus square root b squared minus 4ac over 2a. B is this number. B has a negative sign in front of it in the quadratic formula, so we would put a negative 24 plus minus square root of 24 squared minus 4. A is 7, C is 9. The whole thing divided by 2 times A, that is 7. Now the first thing we would be doing is solving everything under the square root sign. So negative 24 plus minus would go as is. Inside the square root, we have 24 squared, that is equal to 576 minus 4 times 7 times 9, which is 252. The whole thing divided by 2 times 7 is 14. 576 minus 252 gives us 324. We take the square root of 324 and we get 18. Now what is the meaning of this plus minus sign? This means we would get two values. One is with the plus sign and one is with the minus sign. So how do we separate this out is negative 24 plus 18 divided by 14. And the other one is negative 24 minus 18 divided by 14. Negative 24 plus 18 we get is minus 6 over 14. And negative 24 minus 18 divided by 14 we get is minus 42 divided by 14. This gives us a negative 0.43 if we round it to 2 decimal places, and this one gives us a negative 3 value. So these two values that we have obtained when we use the quadratic formula are called the zeros of the given equation, or two x-intercepts for the given quadratic equation. We know zeros are represented as r and s in the factored form. As the factored form is y equal to ax minus r x minus s, we can use these zeros to sub into the factored form r and s values. So we get ax minus negative 0.43, that would give us x plus 0.43, and x minus negative 3 gives us x plus 3. Now where would this a come from? A from the standard form would come down as is, so we need not calculate the value of a, and since our a was 7, we would sub in a as 7 in the factored form to get the complete equation for factored form of this question. And this is how we change the standard form of quadratic equation to factored form of quadratic equation using the quadratic formula. All we have to do is just memorize this formula and apply it carefully using the correct values of a, b, c in order to get the correct factored form of the quadratic equation. One more thing that we need to understand from this quadratic formula is what is the meaning of discriminant and the roots in the quadratic formula. Let's understand that with the help of an example. Now we know this is the quadratic formula. Everything under the square root sign, that is b square minus 4ac, is termed as discriminant of the quadratic formula, and this discriminant value tells us the number of roots the given equation is going to have when we are given the equation in standard form of quadratic relation. For example, if we have 4x squared minus 12x plus 9 equal to y, and we are asked to find the number of roots. We know the other name of roots is x-intercepts the above equation has. Now why do we need to find out the number of roots or x-intercepts the above equation has? Is whenever we draw parabolas can be made in three ways. One form is this: when the parabola is opening downwards and it crosses through x-axis at two different points. So in this state, the parabola has two x-intercepts, or we can say two zeros, or we can say two roots. If the parabola that opens downwards has the vertex lying on the x-axis, so that means it touches the x-axis only at one point, so it would have 1 0 or 1 root. And if the parabola that opens downwards has a vertex somewhere below the x-axis, it will never be able to cross through the x-axis. So in this case, it has 0 zeros or roots. Similarly, if the parabola that opens upwards crosses through the x-axis at two different points, it would have two zeros. If the vertex lies on the x-axis, it would have 1 0, and if it is above the x-axis completely, then it would have no zeros. Now what quadratic formula helps us do is, without solving the complete equation, it tells us whether the given parabola is going to have two answers, or two zeros, 1 0, or no zeros. And for that, we need to solve for discriminant value. We know discriminant of the parabola is represented with b square minus 4ac equation. If the discriminant value is positive, we would have two answers, or we would have two zeros for the given parabola. If the discriminant value is negative, we would have no zeros for the given parabola. And if the discriminant value is 0, we would have 1 0 for the given parabola. Now in this particular example, we know a is equal to 4, b is equal to negative 12, and c is equal to 9. So we would sub in the values of b, a, and c. Negative 12 whole square minus 4, a is 4, c is 9. We get discriminant as 144 minus 4 times 9 is also 144. So the discriminant value that we get is 144 minus 144, that is equal to 0. Because the d value matches this condition, that means for this equation, we would have one solution, or one root, or 1 0, or one x-intercept. So whenever the question asks us to find the number of roots or x-intercepts any quadratic equation that is given to us in standard form has, we always use the discriminant and we solve for the discriminant value. If discriminant value we get is a positive number, be it any number, it just has to be a positive number, then the number of roots that particular equation is going to have is 2. If the discriminant value is any negative number, then there will be no roots for the given equation. And if the discriminant value is 0, then there will be 1, 0 for the given equation. Therefore, now we understand that the quadratic formula helps us not just to find out the roots, but also the discriminant of the quadratic formula helps us to find out the number of roots the given equation is going to have.